The small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Taurus. We are top on the Everest. Congratulations.
I want to be a leader.
Good afternoon, everybody. My name is T.Ashwini, studying in 10th standard at Kammadanam in Mahabubnagar district. Today, I would like to teach you the subject is mathematics. Let's move. Where are you now? I suppose you are in school. How do you start your school? Yes, your school starts with assembly. How do you gather in assembly? Yes, section wise, class wise, height wise, ascending order or orderly. Can you give some more examples where you can see this type of order? Yes, pillars of a building, books in a library, clothes in a cupboard, plants in a garden, and ants path, etc. Can you tell the other word for order? Yes, that is sequence. The other word for order is sequence. What do we mean by sequence? Yes, sequence means it is a list of numbers in which there is a specific relation between 2 consecutive terms and which follows some order that is in increasing or decreasing. What do we mean by sequence? Sequence means it is a list of numbers in which there is a specific relation between 2 consecutive terms and which follows some order that is in increasing or decreasing. Here I give the example, that is 3, 6, 9, 12 and so on. Here this 6 is obtained by adding 3 to the preceding term of 6. That means the preceding term of the 6 is 3 in this progression. So, if I add 3 to the preceding term of 6, that means 3 plus 3, it becomes 6. And this 9 is obtained by adding 3 to the preceding term of 9. That means 6 is the preceding term of 9. Here I am adding 3 to the preceding term of 9. That means 6 plus 3, it becomes 9, 12 and so on. Now let's move to terms of sequence. What do we mean by terms of sequence? Yes, different numbers of a sequence is known as terms of sequence. Different numbers of a sequence is known as terms of sequence. This terms of sequence is denoted by terms of sequence. This terms of sequence is denoted by T1, T2, T3 and so on Tn. Here 1, 2, 3 and n are the subscripts. These subscripts denotes the position of the term. These subscripts denotes the position of the term. And here this Tn is the general form of an arithmetic progression. This Tn is the general form of an arithmetic progression. Now let's move to finite sequence. Finite sequence. what is finite sequence? Yes, the sequence which is countable is known as finite sequence. The sequence which is countable is known as finite sequence. Here I give example, that is, what is the strength of your classroom? Maybe 40 members. So, it is a finite sequence. Now, let us move to infinite sequence. The sequence which is uncountable is known as infinite sequence. What do we mean by infinite sequence? The sequence which is uncountable is known as infinite sequence. The sequence which is uncountable is known as infinite sequence. Here example T1, T2, T3 and so on. These are this sequence, terms of sequence, finite sequence and infinite sequence are all involved in an arithmetic progression. So, today I would like to teach you an arithmetic progression. What is our topic? Today our topic is an arithmetic progression. In our daily life, you must have observed that many things follow certain pattern, such as grains of a maize corn, spirals of a pineapple, holes of a honeybee comb, petals of a sunflower, spirals of a pineapple, etc. These here the pattern is involved. Now, let us see the pattern which occurs in our daily life. Example, Shri applied for a job and she got selected. Shri applied for a job and she got selected. She has been offered with starting monthly salary 20,000 rupees. She has been offered with starting monthly salary 20,000 rupees with an annual increment 2,000 rupees. Can you tell what will be her salary for second, third, fourth years? Let us see. The salary of Shri for second year, third year and fourth year. The salary of Shri for second year is 22,000 rupees. For third year 24,000 rupees and for fourth year 26,000 rupees and so on. Here this 24,000 is obtained by adding a fixed number to the preceding level, that means 22,000 plus 2,000 it becomes 24,000, and then this 26,000 is obtained by adding a fixed number, that means 2,000 here I am adding to the preceding term of 26,000, that means the preceding term of this term is 24,000. So, 24,000 plus 2,000 it becomes 26,000. Let us see here. Here there are some levels of coins. Here there are some levels of coins. And here I am adding one coin to the second level, third level, fourth level, fifth level. Here this successive level is obtained by adding a fixed level of coin. That means here I am adding one coin to the preceding level. So, this successive level is obtained. In the same way, third level, this successive level is obtained by adding a fixed coin to the preceding level. In the same way, fourth, fifth levels. Now, let us consider the list of numbers. given in first case 2, 4, 6, 8 and so on, and given in second case 30, 70, 110 and so on, and given in third case 3, 3, 3, 3 and so on. Can you write the next term of the above list? How will you write? Yes, by following a rule or a pattern. Now let us see the pattern which is involved there. Here I can write after 8, 10, 12, 14 and so on. Here you can see that this 4 is obtained by adding a fixed number to the preceding term of 4. That means here the 2 is preceding term of 4. So here I am adding 2 to the preceding term of 4. That means 2 plus 2 it becomes 4, and the 6 is obtained by adding 2 to the preceding term of 6. That means 4. 4 plus 2 it becomes 6, and 8, 10, 12 and so on. Coming to second case, here this 70 is obtained by adding a fixed number, that means 40 I am adding to the preceding term of 70. That means here 30 is the preceding term of 70. 30 plus 40 it becomes 70. And here this 110 is obtained by adding a fixed number, that means 40 to the preceding number. Here the 70 is preceding number. So 70 plus 40 it becomes 110. Here I can write 150, 190 and so on. Coming to third case, here this 3 is obtained by adding 0 to the preceding level. That means here the preceding level of the 3 is 3. 3 plus 0 it becomes 3. 3 plus 0 it becomes 3. 3 plus 0 it becomes 3. Then 3, 3, 3 and so on. So such lists and such levels are called an arithmetic progression. So today I would like to teach you an arithmetic progression. An arithmetic progression means it is a list of numbers. It is a list of numbers in which each term is obtained by adding a fixed number to the preceding level except the first term or except the first level. So what do we mean by an arithmetic progression? An arithmetic progression means it is a list of numbers in which each term is obtained by adding a fixed number to the preceding level and except the first level. And that fixed level is called an common difference. The fixed level what we are adding is called common difference. This common difference is denoted by D. This common difference is denoted by D. Remember that this common difference can be in positive, can be in negative or either 0. This common difference can be in positive, can be in negative or either 0. Now let us take the general form of an arithmetic progression. And in arithmetic progression, we are considering the first term of an arithmetic progression with A1. The first term of an arithmetic progression is considered as A1. And here I am adding 0 D's to the A. That means here I am adding 0 D's to the A. And I am expanding that. That means A plus 1 minus 1 into D. So that becomes A plus 0 D, A. And the second term of an arithmetic progression is considered as A2. And here I am adding 1D to the A. Here I am adding 1D to the A. Then here I am again expanding 2 minus 1 into D. That equal to A plus D is the second term of an arithmetic progression. And then the third term of an arithmetic progression is considered as A3. And here I am adding 2 D's to the A. and again I am expanding, that is a plus 3 minus 1 into d. So, the third term of an arithmetic progression is a plus 2d. And we know the general form of an arithmetic progression is an. An is the number which comes at nth term, that means after many numbers. So, then the nth term of an arithmetic progression is, here I am adding n d's to the a. Here I am adding n d's to the a, and I am expanding that a plus n minus 1 into d. So, that becomes a plus n minus 1 into d. So, this is the nth term of an arithmetic progression. This is the nth term of an arithmetic progression. See here, the first term of an arithmetic progression is a, considered as a1, and the first term of an arithmetic progression is a, and the second term a plus d, and third term a plus 2d, and the nth term of an arithmetic progression is a plus n minus 1 into d. Now, let us understand this by an example. Let us take the first term of an arithmetic progression is a is equal to 4, and given the common difference d, and given the nth term 5. So, now we are going to find the fifth term of an arithmetic progression. We are going to find the fifth term of an arithmetic progression. So, the general form of an arithmetic progression is an, that means a plus n minus 1 into d. Substitute the values here. Here we are going to find the fifth term, that means T5 is equal to, given a is equal to 4 plus given n is equal to 5 minus 1 into d. Then T5 is equal to, that means fifth term of an arithmetic progression, 4 plus 5 minus 1, 4, and here d given 2. Then T5 is equal to 4 plus 4 2s are 8. That means the fifth term of an arithmetic progression, 8 plus 4, it becomes 12. So, the fifth term of this progression is 12. Now, let us check whether the fifth term of an arithmetic progression is 12 or not. Given the first term of an arithmetic progression 4, the difference is 2. That means 4 plus 2, it becomes 6. 6 plus 2, it becomes 8. 8 plus 2, 10. 10 plus 2, 12. 1, 2, 3, 4, 5. See here, the 12 is the fifth term of this progression. So, here we got the fifth term of an arithmetic progression is 12. Hence, we proved that the nth term of an arithmetic progression is a plus n minus 1 into d. See here, there is another example here, given a is equal to 2, given d is equal to 2 and n is equal to 12. And we got, by substituting the values, the nth term of an arithmetic progression is 24. Now, let us see the sum of the nth terms. Sum of the nth terms. Here we are considering the first sum by first term, second term, and so on nth term. So, the first term of an arithmetic progression is a plus 2d and a plus n minus 1 into d. Then for our convention, we have to reverse the numbers. So, the nth term of an arithmetic progression is a plus 1 n minus 1 into d, comma, the second term of an nth term is a plus n minus 2 into d, and so on a plus d and a. Here Sn and Sn, it becomes 2Sn, adding of these two sums. That means here we have to add the first term and the last term. That means a plus and a plus n minus 1 into d, and it will comes a plus a 2a plus n minus 1 into d. In the same way, if we add the second term of this progression, that means a plus d and a plus n minus 1 into d. Let us see here. Here this is a, this is the second term a plus d, a plus 2d, a plus 3d and so on. And here we are adding the common difference d. Here I am adding 1, that means a plus d, and here I am adding 2 d's, that means a plus 2d, and here I am adding 3 d's, that means a plus 3d. And also here this is a plus d, a plus 2d, a plus 3d. So it becomes 2a plus n minus 1 into d. Then 2Sn is equal to 2a plus n minus 1 into d. And here we are finding the nth term of the sum. So n into 2a plus n minus 1 into d. By transposing this 2 to that side, that means n by 2 into 2a plus n minus 1 into d. So the sum of the nth term is n by 2 into 2a plus n minus 1 into d. Let us understand this by an example. The sum of the nth terms is what? Yes, n by 2 into 2a plus n minus 1 into d. Here given the first term of an arithmetic progression with 5 and with common difference d is equal to 4, and given the nth term is 5. So we have to do the sum of this progression. So Sn is equal to n by 2 2a plus n minus 1 into d. By substituting the values, that means Sn is equal to, we are going to find the fifth term, 5 terms of the sum, that equal to given n 5 by 2 2 and given a is equal to 5 plus given n is equal to 5 minus 1, given the difference is 4. Then the sum of fifth terms is 5 terms, that means 5 by 2 into 5 2s are 10. 10 plus 5 minus 1, it becomes 4. Then 5 by 2, 10 plus 4 4s are 16. Then 5 by 2 into 26, 10 plus 16, 26. Then cancellation, 2 1s are 2 3s are, that means 13 into 5, 65. So the sum of 5 terms of this progression is 65. Now let us check whether the sum of the 5 times is 65 or not. Given the first term of an arithmetic progression with 5 and with common difference 4, that means 5 plus 4 it becomes 9, 9 plus 4 it becomes 13, 13 plus 4 it becomes 17, 17 plus 4 it becomes 21, 21 plus 4 it becomes 25. Now let us do the sum, 9 plus 5, and then the value what we get we have to add here, that means 9 plus 5 it becomes 14, 14 plus 17, 13 it becomes 17, 17 plus 17 it becomes 24, and 24 plus 21 and then 20, the value we get on the sum here. Then we got the sum of 5 times is equal to 65. See here. Here given AP 12 plus 20 plus 28 plus 36 and so on. We have to do the sum here. the first term of an arithmetic progression is 12 with common difference 20 minus 12. While we are doing a difference, while we are going to find a difference, we have to subtract from second term to first term. That means 20 minus 12 becomes 8, and the sum of n terms Sn is equal to n by 2 into 2a plus n minus 1 into d, and given n is equal to, we are going to find the sum of 30th term. So, 30 by 2 into 12 plus 30 minus 1 into 8, and then 2 ones are 2, 15s are 30. So, 15 into 24 plus 29 into 8, then 15, 24 into 24 plus 2, 32, then 15 into 2, 56, it becomes 3619. So, the total terms are 30, and the first term in this progression is 12, and with common difference given 8, and the sum of the 30 terms is 3690. You can see here the difference is given $1, and that is a. Here the second term of the arithmetic progression is a plus d, and here we are adding 1d to the a, that means a plus d, and then a plus 2d, and so on, a plus 3d. And next, the general form of an arithmetic progression is a plus d, a plus 2d, a plus 3d, and so on, a plus n minus 1 into d. And a is the first, we are considering the first term of an arithmetic progression with a and common difference d. Here the general formula, we know that a plus n minus 1 into d. Here there is, in the sequence there is a common difference, there is a fixed number is the difference, and this is the general form of an arithmetic progression, that is a plus n minus 1 into d. Let us see an example. Here given a is equal to t with common difference 2, and we are going to find here that term is 12. Formula, then given a is equal to 2 and given n is equal to 12, 12 minus 1 into d, then 2 plus 11 into 2, then 2 plus 22, 11 2s are 22, then an is equal to 24. And hence we solved by the general formula, that is an is equal to a plus n minus 1 into d. And this is also one example. Now let us see the example for finding the sum of nth terms. So, we are considering the first term of an arithmetic progression with a, and the last term is a plus n minus 1 into d. So, we got that the formula, here we are adding from first term and the last term, that means a is the first term and a plus n minus 1 into d is the last term. So, we got that the sum of the nth terms is equal to n by 2 into 2a plus n minus 1 into d. And here there is an example, that is given a is equal to 100, and we are going to find the nth term, the sum of nth terms is 500. With common difference, while we are doing a difference, what we have to do? We have to subtract the first term from second term. Here the second term is 105, we are subtracting 105 minus 100. So, the difference is 5. Then an is equal to a plus n minus 1 into d. Then given an is equal to 500, that equal to substituting the values, that means 100 plus n minus 1 into 5. Then transposing the 100 plus 100, it becomes minus 100. Then 500 minus 100 is equal to 5 into n minus 1. Then 500 minus 100, it becomes 400, that equal to 5n minus 1. So, 5n minus 1 is equal to 400. Then n minus 1 is equal to, here the 5 is taking the multiplication there. So, by transposing it becomes division. So, 400 by 5. Then n minus 1 is equal to 80. Then n is equal to 80 plus 1. So, the nth term of this progression is 81.